When you add and subtract fractions, you always need to make sure of one thing first, that you are adding pieces that are equal sizes. It wouldn't be fair if I told you that here, this is how much you get, and this is how much your best friend gets. Because it's fair because they're both one piece. No, they're both pieces, but they're different sizes, and your best friend might be feeling pretty left out with a tiny piece while you get the giant piece. So when you are adding or subtracting, you need to make sure that all your pieces are the same size in what they're cut up into. For example, we could cut your piece into 4 pieces, and now this piece is equal in size to this one, which is equal in size to this one, which is equal in size to this one, which is equal in size to the original one your best friend got. They all have the same size, so it wouldn't matter if you got this piece or this piece or this piece. They're all the same, and you would be okay with getting any of them. That concept is called having common or like denominators. Remember, the denominator is the one that tells you the size that your piece is cut into. Your numerator tells you how many of them there are. So for example, this green with purple slices would be 4 out of, let's see, it would take 1, 2, 3, 4, 5, 6, 7, 8 to make a whole piece. Okay, let's look at some examples. When you have common or like denominators, let's say you have 5/6 minus 2/6. That is 1, 2, 3, 4, 5 pieces minus 1, 2 pieces that are the same size. So we know that our answer will have the same denominator. We're still talking about pieces that are 1/6 of a whole. And if you have 5 and you take away 2, here's 1, 2, 3, 4, 5. And I'm going to take away this one and take away this one. I'm left with 1, 2, 3 pieces, which is the same thing as 5 minus 2 is 3. Now, just because you subtracted your common denominators doesn't mean that you can forget the last step, which is to check. This can simplify, and if it can simplify, then you must simplify it, even if it means that your answer is no longer in sixths. This is equivalent to 1/2, and that is your final answer there. What about when you're adding? If I have 1/4 plus 2/4, I have like or common denominators of fourths, which means that my answer is going to be in fourths. Then I add my numerators. 1 plus 2 is 3. I check, can I simplify 3/4? No. So 3/4 is my final answer. When you have common or like denominators, you can go ahead and add or subtract them. However, when you see a problem that has uncommon or unlike denominators, you need to figure out what your common denominator is going to be before you can add or subtract your problem. All right, the way I do it is I ask myself, does 4 multiply times a whole number to equal 2? 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12. Nope, that's not going to work out. Does 2 multiply times a whole number to equal 4? 2 times 1 is 2, 2 times 2 is 4. Ooh, yes. Okay, so if I can multiply one of my denominators to equal the other one, I'm only going to change that fraction, and I'll leave the other fraction the same. So I've got my 1/4. I'm going to now multiply. What did I say? I said 2 times 1 is 2, 2 times 2. Yeah, there we go. Times 2 is 4. What I do to my Denominator I have to do to my numerator because what I'm really doing is multiplying times a fancy 1. 2 times 2 is 4. 2 times 2 is 4. Now that I have a common denominator, I know my answer will be in fourths, and I can add 1 plus 4 is 5. You have the choice. Since 5/4 is technically the most simplified improper fraction, you can leave it like that. Or you could also say 1 whole and 1/4. Both of those are acceptable. You can present your answer in whichever case you like best. Let's try another example. If I have 3/20ths plus 1/5, well, what's my answer going to be? Can I multiply 20 times a number to equal 5? 20 times 1 is 20. 20 times 2 is 40. 20 times 3 is 60. Nope, not working out for me. Can I multiply 5 times something to equal 20? 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is, 20. All right, so I'm going to change my 1/5 and find its equivalent form in 20ths. 3/20ths stays the same. 1/5. Well, if I want it to equal 20ths, I'm going to have to say 5 times 4 is 20 times 4. 1 times 4 is 4. All right, now we have 3/20ths plus 4/20ths equals 7/20ths. I cannot simplify that, so that's my final answer. Last example. If I have 1/6 plus 1/8. Gonna do my check. Can I multiply 6 times something that equals 8? 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is... nope, that's not gonna work. Can I multiply 8 times something that equals 6? 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. Nope, not gonna hit 6. What do I do now that neither of them can be changed to have the denominator that the other one has? I'm going to have to change both of them. One strategy you can use is to multiply times a fancy 1 of the other denominator. So 1/6, the other denominator is 8. I can multiply times a fancy 1 of 8/8. This will always work. It might not always be the simplest common denominator, but it will always be a common denominator. If you think you can find a more elegant solution, a better one, you go for that. But this one will always give you equivalent fractions. You'll just have to simplify. All right, notice my 1/8 is multiplied times a fancy 1 of the other denominator. My 1/6 is multiplied by a fancy 1 of the other denominator. I'm ready to multiply. 1 times 8 is 8. 6 times 8, let's see, what's that going to be? 6 times 8, 48. 1 times 6 is 6. 8 times 6 is 48. Quick check. 6 times 8 is 48. 8 times 6 is 48. What's that property called? That you can multiply in any order and it will still equal the same answer. Oh yeah, the commutative property. That doesn't really have anything to do with what we're talking about now, but it's a good thing to keep in the back of your mind because it's definitely something you'll see on the star. Okay, so 1/6 is equivalent to 8/48, and 1/8 is equivalent to 6/48. Notice I could in this moment simplify both of those fractions, but if I simplify them, they're going to simplify back down to 1/6 and 1/8, and then my scaling up was pointless to find a common denominator. Generally, finding the common denominator means that you're not the most simplified form, but you'll simplify your answer. 8 plus 6, well 8 plus 2 is 10, plus another 4 is 14. 14/48 is not your final answer. Now is when you simplify. 14 over 48. Let's see. I could start by listing all my factors of 14 and 48 and find what I have in common. Or I can start with my divide both numerator and denominator by 2 since they're both even strategy. Either way, let's see. 14 divided by 2 is 7. 48 divided by 2 is 24. My factors of 7 are 1 and 7. It's a prime number. My factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. Other than 1, I do not have any common factors, so 7/24 is my final answer.